Hello, this is Michael Scott and Stephen Duncan. We're here to present to you the Trail Analyzer 2K15, a GIS and analyzing program for biking trails. We're students at Brigham Young University in this CE594R class taught by Dr. Dan Ames. The objective of this project was to analyze biking trails using digital elevation models and be able to score those results. We did so using C# and programmed in Visual Studio. The outline of our video is as follows. First, we will talk about our coding, including our GitHub setup, the design of our form, the extensions and DLLs that we used, as well as the form functions. We'll then talk about the program itself, including a demo, show you some sample data available to the user upon download, and then also how the user can import and create their own data. We'll then conclude. Okay, so this is what our program looks like, and I'll talk about the form design. We try to keep it as simple as possible so it would be easy for the user to use. So we used a series of buttons to be able to operate the different functions, a few small buttons to move the map around, zoom in, pan, and then some of the custom controls that are from .spatial, which include this map legend, the map that will go here, which is also a .spatial control, and finally the Z-graph control. And these are included when you download the DLLs and include them in the project. You're able to use the .spatial and the Z-graph controls. A couple other tools we used down here is our status strip and our progress bar, which appear when needed. And other than that, it's just a simple, clean design and hopefully easy to use.
So in addition to the Z-graph and the .spatial DLLs that we've loaded into our program, we also need to load in extensions into our program, and the extension that we used is called GDAL. And what this allows us to do is it allows us to import additional raster formats that were not initially supported by .spatial, and we do that by putting inside of our folder, inside this location up here, we have an extra folder inside our debug folder called application extensions, and this forces the user to load in the GDAL extension, which allows the user to import the additional formats for rasters, because not everything comes in a BGD format. So here inside of our code, we've also created some sample data buttons that the user can use to compare their trails to technically rated trails that we've downloaded from online. And we do this by catching any previous data and deleting it off the map. We add the new sample data, and then we analyze and plot the Z-graph. So here we use a try catch to see if there's any layers on the map, and we delete them if they are there. Of course, then we add the sample data, and we add that from our data folder that we provide. And then we use the analyze and plot on the Z-graph, and we do that by using the analyze trail hardness plot function that we created. And then it does some editing to the Z plot, and it refreshes the plot so that we can see it. And then it also changes the tab control so that it switches over from the map to the graph and the interesting stats about the sample plot that we'll show you in the when we do the example. So now we're going to show you how the analyze trail hardness function works inside of our C# code. And so we have it divided into these 5 different sections: the find trail elevations, calculating plots, the Z-graph curve, the algorithm, and the dialog rating labels. And so first here in the find trail elevations, what we do is we create a temporary coordinate, and we kind of just step through each one of the coordinates based on the how many features are inside of our, or how many vertices are inside of our shapefile. And we're going to step along each one of those vertices according to the cell width inside of the input raster that we give it. And so we find a y and an x, and what we do is we extract the z coordinate from those points. Or from the raster, and then we add that to a list called my extracted points. So that's the end of this first region here. The next thing that we do is we do the calculating plots. And so what we do is we take that my extracted points and we create a plot x for the graph and a plot y based on, or the plot x is based on the hypotenuse between the x and the y, and the plot y is actually based on the elevation for each one of those sections. And so while we're doing those sections, we're actually keeping track of some of the interesting features of our trail so that the user can see them at the end, such as we're keeping track of the uphill distance and the uphill total climb and the downhill distance, and etc. So we do that there in this section. Then the next section that we have here is that we're going to plot the z-graph curve, and this is fairly simple. What we do is we select the z-graph plot, and what we do is we graph a new curve based on our plot x and plot y that we calculated. We add the new cross section, and we can give it some symbology as well, such as forest green for the line, and then the fill underneath it, we go from a light blue to a navy blue, and we can give the line some thickness too. And then our next step is to move on to the algorithm where we rate the trail.
So the next step after graphing the plot is to determine the hardness of the trail. We developed an algorithm to do this, and it's within the analyze trail hardness function. So within the algorithm, we set up a couple variables, and then we chose 5 different aspects of the trail that we would keep track of, and then gave each one a different weight to determine the final difficulty. One of the more interesting ones is the slope. And so I have 5 different categories of slope, and as we loop through each of the raster cells which the trail crosses through, I keep track of the how many times the slope falls within each category. The categories are less than 0, 0 to 0.1, 0.1 to 0.3, all the way down to greater than or equal to 0.4. And as I keep track of those, we can then look at what percentage each of those slope categories contains. And so we can say, well, the slope E has 10% of the trail, and then 15% of the trail is a slope A. And then once I have that, we can then give a weighted value to those. So if there is more than 10% of the slope is a slope E, meaning greater than 0.4, then we're going to add. Then it's going to receive all 4 points possible. We did a similar process for the percent slope, the maximum slope, so that's uphill, the total distance, and the total uphill climb. All of those areas have 4 potential points, and they can add up to a total of about 27 points after they're all done. And with that, we can then determine right here the total difficulty, add up all the points for that trail, and then see which category it fits into. So a pretty straightforward algorithm. You'll see when we run a sample that with the graph there's the difficulty, but there's also a few other statistics that might be interesting to writers. And we kept track of those in our dialogue rating labels region. And all of these, the difficulty level was calculated in the algorithm that I just explained. but all the others were calculated during the graphing process. We just kept track of the different numbers that we wanted to find, and are able to display those in an easy to understand fashion.
So here I'm going to show you how to use some of the sample data that we've provided in our Trail Analyzer 2K15. So here you can see that we have the sample trail data right here, rated in technical difficulty from easier to extreme. And so if we click here on the easy button, has to load in the data. Here it loads in the raster and the shapefile, and then it calculates the different elevations across our shapefile, and we can see here that even though this is a technically easy trail, the physical difficulty is moderate, along with some other interesting stats about this trail. And you can do this with all several different trails that we've downloaded from online.
I will now show how the user can create their own data. You can import a raster in a variety of formats. I'll go to some of our sample and these that were used earlier. Now we can name the entity my DEM, for example. And then we can import a trail that's already created, and I'll navigate to one that I've created earlier. And I can name that my new trail. Great. And then we can graph it. And we can see that this is a difficult trail. It's relatively long at 5 kilometers and a good amount of climbing with a good slope. I'll now go back to the map. I'll delete this trail, which you don't have to delete, you can just draw a new trail. And then we'll try drawing our own trail. You can see that the commands on the bottom here are telling me how to do it. And then you simply just click on the trail, double click to finish, and name trail. I'll use the same name, my new trail. Replace it. And then we can graph this trail. We'll see that this is also difficult and it's mainly uphill. So not a trail I would ride on. Anyways, this concludes our demonstration of Trail Analyzer 2K15. Hope you enjoyed it.
This concludes our tour of the Trail Analyzer 2K15 and the code behind of it, and our project as well. So thank you for watching, and if you'd like to download our source code, you can do this at our GitHub in our organization, GIS Bike Dragons, and you can download it. It's here in this repository called Trail Analyzer 2K15. So thank you very much for watching.